Hello and welcome to the Shadow Project, where we are trying to make 3D printed dog orthotics. My name is Benjamin Kailes, and I am a biomedical sciences major interested in pursuing rehabilitation engineering and medical school as my career paths.
Hey everyone, my name is Kingsley Ononogbu. I'm currently studying chemical engineering at USF, and I plan on furthering my education by studying more on solar energy.
Hi, my name is Amanda Parilla, and I am a mechanical engineering major with a hope to pursue design and manufacturing as a career.
Hello, my name is Nat Wehala, and I study chemical engineering with a hope to pursue research and development as a career.
Shadow is a service dog that served in the military for a couple of years. Right now, currently, she has gone through a bunch of difficulties. She recently went through cancer. She had to remove a brain tumor, and she also suffered from a stroke. As a result of all of this, she had a problem in her hind leg, specifically her right hind leg. Our group was given the task of developing an orthotic device that would help her and aid her and allow her to still enjoy a full range of motion.
Currently, she has a harness that her owners can use to pick her up and a very extended boot that is not entirely comfortable but serves to aid her somewhat. So now we fall into the purpose of this project.
Of this project is to design a device for Shadow that allows her to have a full range of motion. The key goals for our device was to make sure that it was cheap, to make sure that it is very effective, to make sure that it's a custom fit orthotic device for Shadow, and to develop this device, we made use of 3D printing. This was helped by the USF 3D printing team.
Our inspiration came about by wanting to improve on and enhance Shadow's current boot. We carefully thought about where Shadow experiences pain and weakness so that the pieces we built would support those parts of the leg. Shadow struggles to maintain weight and support in her left leg, knee, and hip, thus having to lay down often. Therefore, we concentrated on keeping her current boot, but with a sturdier support and elevation, as well as creating a knee brace to support the knee and hip. The knee brace is essential because Shadow would limp and drag her leg without any support for her to straighten the knee and stand upright. It was decided that the boot would be made out of a flexible material such as TPA, thermoplastic elastomer, and a rigid material for the knee, PLA, polylactic acid.
For the first boot that we made, it was a form-fitting device made out of rigid material as it was a prototype. Since we had scanned Shadow's leg, we were able to use that to make sure that the boot fit. The initial strap design had rectangular strap holes, and we decided to also use a foam and Velcro design for cushioning on the inside, where Velcro would be attached to the foam and attached to the boot, and the foam could then be attached or removed from the boot itself.
Okay, so for our second design, we improved the strap design by including slits that allows us to fit it in a zigzag pattern. We also increased the boot space to increase the comfortability and to allow more space for foam to be fitted into the boot. We made use of flexible materials, and we also shortened the length to prevent any joint pain or joint discomfort.
For the third phase of the design, we wanted to implement a sewed pocket that holds the foam padding for more comfort against the skin. We chose to stick with the same flexible material as boot design number 2 and had to reprint this material for a more polished and neater look. But since it was printed too quickly, it had created some hollow pieces around the top that became less supportive for this design.
We also added a sewed pocket for the foam in order to make it an interchangeable cloth that could be cleaned. In addition to that, we also made the paw thicker and opened up the design to make it more accessible.
For our fourth iteration of the boot, the slower print yielded a more stable and supportive product. We saw that the padding was necessary for her comfort, so we added a pad of EVA foam for the midsole and moleskin lining to protect her skin. For grip, we added a simple rubber tread on the outsole, and we also found that the straps were too cumbersome to use, so we simplified the design as well.
Okay, so an update on Shadow. Recently, Shadow suffered yet another stroke, so this set her back, and we weren't able to bring Shadow in for testing or for any measurements. As a result of this, we had to make our project more general and more open. So we made some modifications and made the project so that it could be used for any and every dog.
After much deliberation, we've decided that it would be more cost-effective to hand fit our own joints that we found on Amazon. This way, we hope to inspire others to see that all this can be made at home. Our design for the knee support is a semi-mobile hinge joint that is held together with two braces, one for above and one for below the knee, as you can see in the diagram on the right and the real version on the left. As you can see, first iterations proved too small to fit the joints, so the sides were extended on both plastic parts to account for the size of the joints. Massive alterations are done to the initially purchased brace to fit Shadow's leg shape better by drilling holes that allow adjustment of the length.
With all the materials collected, we will demonstrate how to put together the orthotics.
Hello everyone, here are all the pieces for Shadow's orthotics. And as you can see, all the pieces are removable, and on the reverse side of the paddings, there's Velcro for easy anchoring and easy removal. And all of the paddings are just gonna be placed inside just like that, and you're done. Easy access, you can take it off. It is machine washable, so cleaning is easy. And then for the boot, you just slip it in and strap in the Velcro. Easy as that. Then the straps are looped through to make a tight fit. Once all the straps are on, the upper knee brace can be now attached. And it goes on like so, just like that, easy slip on, and then strap in with Velcro to secure it in place. The back strap for extra support, and that's what gives the hinge its elastic motion. And the top upper strap as well for extra support. As you can see here, this is the final product, and I'm demonstrating how it should move on Shadow's body.
So, as a part of our results, was the purpose of the project achieved?
Our product did achieve all the components we wanted to include, therefore it was successful. On the other hand, due to Shadow's lack of participation because she was ill, we were not sure if the product accomplishes straining and supporting Shadow's knee and hip. As a result, we tested our product on a different breed dog, which was not successful due to the measurements being too specific toward Shadow. The pieces were too big, but we do know that these pieces in the future can be customized to the fit and the need of other dogs and their breeds.
And now for our conclusions.
A cheaper market alternative was created with customization potential for a wide range of dogs. However, the supportive potential was undermined due to the time constraints and unavailable test subjects.
The key takeaways from this project/process is that the whole entire design process from brainstorming to manufacturing is essential. Having a plan and a goal to work toward is important, of course, but the process in itself is so critical because it is a constant revision and modification of parts and ideas until the final product comes together. Anything can be achieved in a design. It is just a matter of, is it realistic, affordable, and doable within a given time frame? I believe this product has taught our group the process of designing and manufacturing an item for a partner, which relates to real-world experience as an engineer.
There are a variety of work and applications that can be done moving forward. First off, it could be a do-it-yourself technology that could either work as something that is cheaper for people to do at home to create an orthotic for their own dog, or it could be used in an educational setting to teach people about 3D printing and about creating orthotics. For future work, the team would like to explore creating a 3D printed hinge in order to drive down the cost instead of having to purchase off Amazon, and also to look into how to make a 3D printed hinge something that's customizable depending on the dog. Finally, for future work and applications, it was thought that if this were to become a marketable product in the business environment, it would be pertinent to create upgradable options like a carbon fiber plate for the EVA foam or other features in order to meet the demand in the market.